Now second method is called as hexa-axial method, or it is also called as isoelectric method. So now first of all we have to know what are the different leads in an hexa-axial system. So we are measuring the cardiac dipole in frontal plane. So we'll just measure the frontal leads or the limb leads. So lead 1, it is in this direction. Okay, lead 2 in this direction, lead 3, then AVR, it is in this direction, AVL and AVF. Okay, so you have to find out an angle. So in lead 1, this is 0 degree, there is 0 axis deviation, this is plus 90 degree, this is minus 90, lead 3 is 120 and lead AVR is 150. Now what is cardiac dipole? It is an average of electrical activity which is flowing in the heart. So if this is in center of the heart, if you see the heart, there are atria and ventricles. The maximum muscle mass is by ventricles. Okay, so the maximum current flowing is in this direction. Okay, so maximum current flowing is through this ventricular wall in this direction towards the lead 2. So usually the cardiac axis, it varies from minus 30 to plus 110. So it lies in this area from minus 30 to 110. So this is a normal cardiac axis or cardiac dipole. Now in the approximate method we will not be able to find out an angle, but what we can find out is the shift. Now there are two types of shift. One is left axis deviation and the other one is right axis deviation. So when it is moving away in right side, that is more than 110 degrees, we call it right axis deviation. If it is moving in this direction it is away in the left side in anti-clockwise direction, we will call it as an left axis deviation, and when it is falling in this quadrant we will call it extreme axis deviation. Okay, so when the current is moving towards the lead, we know it will give a positive deflection. When it is moving away from the lead current, it will give negative deflection, and if the current is coming towards the lead and it is leaving the lead, it will give positive and then negative deflection. So that is zero axis deviation, that is called as isoelectric deflection across the ECG. Okay, so now how to find out an axis deviation, whether it is in the normal region or it is in the left direction or it is in the right direction. So first step is you have to find out a lead which is having zero deflection, that is an isoelectric deflection. So if you see in this lead 1 is having in this direction the current is flowing, means current is coming and it is going away, so it is having zero deflection, that is isoelectric deflection. Then second is you have to find out an perpendicular axis to that lead. So perpendicular axis to the lead 1 is AVF. Okay, now in this AVF you have to find out what is the QRS complex. So if the QRS complex in this perpendicular lead, it is positive. Okay, in this perpendicular lead it is positive, then the current is flowing in the same direction. Okay, so if you see the QRS complex and the AVF is positive, means current is flowing in this direction, means cardiac dipole is in this direction. Okay, and if the current is moving away from AVF, means QRS complex is negative, then current is moving in the opposite direction, means there is left axis deviation. Okay, so first of all you will find out an isoelectric deflection lead. Okay, then you will find out a lead which is perpendicular to this. So if for an example lead AVL is showing an isoelectric deflection, that is 0 degree, then perpendicular to it is lead 2. Now if lead 2 is showing positive deflection, means current is flowing in this direction. means cardiac axis is normal. If lead 2 is showing negative QRS complex, then current is flowing in opposite direction. Okay, current is flowing in this direction, means there is left axis deviation. Okay, means current is flowing away, means axis is in this direction. So this is how you will find out an cardiac dipole by hex-axial method. Okay, this is an approximate method. Here you cannot find out an accurate angle. Okay, there is one more method that is called as quadrant method. Here you have to just see lead 1 and AVF. Okay, normally if you see lead 1, the QRS complex is positive, the current is moving towards lead 1. If AVF is also positive, then it is falling in a normal cardiac axis. Okay, if QRS complex is negative in lead 1, means current is flowing in this direction, and AVF it is plus, so current is flowing in this direction, means cardiac axis is in the right side, so there is right axis deviation. Okay, because it is going in this direction, as lead 1 it is negative. Okay, lead 1 it is negative and AVF it is positive, so there is right axis deviation. Okay, if lead 1 is positive, means in this direction, and if AVF is negative, means in this direction. Okay, so there is left axis deviation, and if both are negative, means it's going away from lead 1 as well as AVF, means it is extreme deviation. So this is how we find out by quadrant method. So these are the approximate method. First is hex-axial method, second is quadrant method. In hex-axial method, first you will find out an isoelectric deflection lead, then you will find out an perpendicular lead to that first lead. So if the isoelectric deflection lead showing, example in lead 3, there is an isoelectric deflection, so perpendicular to lead 3 is lead 2. So you will see lead 2. If lead 2 is positive, means it is normal cardiac deviation. If lead 2 is negative, means there is right axis deviation. Okay, because it is going in opposite direction. In quadrant method, you have to just see lead 1 and AVF. Okay, and these are the criteria for normal, right axis deviation, left axis deviation and extreme deviation. You have to just see the QRS complex in lead 1 and AVF. Okay, so these are the two methods. Thank you.